Okay, today is February 20th. This is your chapter 2 review of ratio and rate and proportional reasoning. So your first question is your vocabulary. It says, what is a proportion? Now, a proportion in general, a proportion by definition would be what we would call an equivalency when we are dealing with fractions or ratios. So it's like an equivalent is another way to say proportional. So if we look at this, D shows us 7 to 50 is equal to 14 over 100. Or if we're talking about the ratio of, let's say, 7 students to 50 total students, is proportional to 14 students out of 100 total students. Or 14 girls, excuse me, out of 100. So we're going to say D is the answer for proportion. A ratio is a comparison of two parts to each other, either part to part or part to whole. So ratio is one part to another. So right here for B, I changed my color for whatever. So B would be a comparison of 3 parts something to 5 parts another thing. So if we had stars to faces, we can say it's 3 parts to 5. A better one, which would use that exact same, would be this picture. And this ratio would be a part to whole ratio, 3 stars to 5 total shapes. And the reason why we'd use it in fraction form is because fractions generally have part to whole ratios. So if you have it in this form, generally speaking, it's part to part. And if you have it in fraction form, it's usually indicating a part to whole ratio. For question 3, a 3-term ratio. That's about the easiest thing you'll have on here. It's E, a part to part to part, or we use 3-term ratios when we talked about making granola. We also talked about 3-term ratios when we were talking about, what was the other one we used it for? What was it? Was it trail mix? I can't remember the other one. But trail mix was the one I remember. A unit price. Since price has to do with dollars, it means cost per dollar, or dollars per kilogram, or dollars per milliliters, whatever it happens to be. And the one we have here for that is A, which is the cost per tin, which would be the unit price. And a unit rate, given that there are 2 or 3 left, a unit rate means the second term is 1. So G is your answer, because in this one, 120 kilometers for 2 hours is not a unit rate, it's a rate. Question 6 says, use the square tiles pattern to find the answers to each of the following. What's the ratio of red squares to blue squares? So red to blue would be 6 to 6. That's for A. For B, blue squares to total. Since we're dealing with a part to whole ratio, I'm going to set it up like this ratio instead, or 6 to 12 would be the ratio. For C, 2 equivalent ratios for the answers in part B. 6 to 12, equivalent would be 1 to 2, or 2 to 4. Those would be equivalent. You could also go 12 to 24. There are infinite possibilities for C. At part D, percent of squares that are red. Since this is a part to whole ratio, part to whole ratios can be used as percentages. So therefore, 6 out of 12 as a decimal is 0.5, and as a percent is 50%. Question 7, look at the figure. What is the ratio of 2-digit numbers in the red hexagon compared to the total number of 2 digits? So inside this red hexagon here, we have 6 2-digit numbers. And in the entire parallelogram shape, if we count them up, we have 16. So for A, what's the ratio of 2-digit numbers to total? We could do 6 to 16, but since it's a part to whole, it's probably more appropriate to express it in fraction form, since it is a part to whole ratio and not a part to part. For question B, express it as a fraction in lowest terms. Since it's a part to whole, we'll start with that. Both are divisible by 2, which would leave us 3 with 8, and that is the ratio in lowest terms of the numbers in the red hexagon to total numbers in the parallelogram. And question C, what is the ratio of 2-digit numbers containing 2 compared to 2-digit numbers in the red hexagon that contain 2? So if I take my highlighter here and mark all of the numbers that contain the digit 2, I would find that there are 8 total numbers that contain 2. 8 total numbers that contain 2. Compared to, in the red hexagon that contain 2, it's 4. So it's a part-to-part ratio, and therefore in lowest terms, there are 2 digits in total, 2 numbers in total that contain the number 2 to 1 number that contains the number 2 within the red hexagon. Question number 8. Stephanie counted 20 vehicles in the parking lot. Of these, 5 were silver, 4 were blue, 2 were red, and 1 was yellow. What is the ratio of yellow to red to silver vehicles? So yellow to red to silver. If I was doing this test on or question on a test, I would first write that, yellow to red to silver, because I want to make sure my terms are all in the correct order. So the number of yellow vehicles was 1. The number of red vehicles was 2. And the number of silver vehicles was 5. So my ratio has to be 1 to 2 to 5 in that order, because I want to make sure yellow is my first, red is my second, and silver is my third. So that is your answer to A. It's a 3-term ratio. In question B, how many vehicles were not silver, blue, red, or yellow? So not blue, red, silver, or yellow. And since we know that there are 20 vehicles in total, and those 4 that are listed make up 5, 9, 10, 11, 12 of them. So 12 out of 20 total vehicles are those colors. That means that 8 are not those 4 colors, because that's the remainder of the vehicles. Question C, what could the ratio of 4 to 20 represent? 4 is the number of blue cars, and 20 is all cars. So we could say it's a blue to all, or since it's part to whole, it's best to write it as a fraction, blue to all. It could also represent, anything else it could represent? No, it couldn't, could it? That's the only thing it could represent. Question D, what does 5 to 8 represent? The most appropriate one is probably silver cars to all non-silver, blue, red, and yellow. Silver cars to all non-silver, blue, red, and yellow, because all silver, blue, not red, and yellow, the rest of the colors, or I could say the rest of the non-silver, whatever you want to word it as. But the rest of the colors are the 8 other colors that aren't mentioned in the preamble. And question E, express the ratio of silver to total as a fraction in lowest term. So since it's a part to whole, we are going to write this ratio as a fraction. And we are going to put silver as 5 to total, which is 1 to 4, which as a percent would be 25%. Therefore, 25% of the vehicles in the parking lot are silver. Question 9. A football team won 10 of its 18 games and lost the rest. How many games did the team lose? Well, since it played 18 games and won 10, a simple calculation will tell us they must have lost 8 of those games. And what is the win-loss ratio? The win-loss ratio would be 10 wins to 8 losses. In lowest terms, for every 5 times they won, they lost 4. Question 10 we skipped because it's a measurement question. Question 11 says determine a unit rate in each situation. So for A, we have a choice to make. Do we want steps per minute, or do we want minutes per step? And when we look at these two setups, we probably tell ourselves that we want to have steps per minute, which means I'm going to keep the orientation of steps as my top and minutes on my bottom. So I'm going to put 300 steps here in 6 minutes. And in 1 minute, since I'm going to divide both by 6, I would learn that it's 50 steps per minute. But you could have started with 300 steps in 6 minutes, and you could have said, you know what, if I multiply both terms by 10, if I multiply by 10 instead of dividing by 6, I will have 3,000 steps, but I still maintain a unit rate because it's going to be 1 hour. So in either case, you're going to have 50 steps per minute, which is my unit rate, or 3,000 steps per hour. And of course, you could multiply that by 24 and you get how many steps you take a day, but that's probably not going to be very accurate because nobody is going to walk for 24 hours straight. In B, you have a jet travel, or sorry, $3.60 at the price of 4 liters. Do I want cost per liter or liters per dollar? And when I analyze those two rates, I realize I want cost per liter. So I'm going to put $3.60 as my first term and 4 liters as my second. In order to get a unit rate, I can divide both by 4, and I'm going to end up with 90 cents per 1 liter, or a unit rate of 90 cents per liter. Question C, a jet travels 2,180 kilometers in 3.5 hours. Do I want kilometers per hour or hours per kilometer? When I ask that question, I'm pretty sure it's kilometers per hour. So I'm going to keep that as my orientation. 2184 over 3.5. When I divide 2184 by 3.5, 2184 divided by 3.5, I get 624 in 1, which means my unit rate is 624 kilometers per hour. And my final question, D, a polar bear gains 450 kilograms in 9 years. Do I want kilograms per year, or do I want years to 1 kilogram? And of course, kilograms per year sounds the more appropriate, or mass to time. So if I put 450 kilograms over 9 years, divide both terms by 9, I end up with 50 kilograms in 1 year, or 50 kilograms per year as the unit rate. Question 12 says transportation increases the cost of groceries in northern communities. Use data about the cost of grocery items in Winnipeg and Little Grand Rapids to answer the questions. A, give an example of a ratio. And since a ratio is a comparison of two parts of the similar thing, we could say the cost of bananas in Winnipeg compared to the cost of bananas in Little Grand Rapids. So that would be a comparison of two units of the same thing, or $4.98 compared to $13.95, a ratio that would compare those two units. There is also, I could do the comparison of the cost of ravioli in Winnipeg to the cost of ravioli in Little Grand Rapids, etc., etc. There are 3 different ratios you can make. In the second part, give an example of a rate. A rate would compare things like cost to volume, or cost to kilograms, or cost to volume. And since those are all examples of rates, I could make 6 different ones. I could say $4.98 to 3 kilograms of bananas, that is a rate. I could also say $13.95 to 3 kilograms, which is a different rate, but that for Grand Rapids. I could do $2.29 for 720 milliliters, etc., etc. Those are all examples of rates. But in C, it asks us to take the 2 unit rates for bananas. I'll have to unlink these. Hang on a second. Ungroup them. Where's my group button? Right there. Take this one over here. And it says calculate. Oh, no. There, that's better. So we have the unit, or the rate of bananas in Winnipeg here and Little Grand Rapids here. So what it asks us to do is determine the unit rate for both communities. So a unit rate means how much is it for 1 kilogram in each of these 2 communities. If I divide both terms by 3, $4.98 divided by 3 tells me that the unit rate is $1.66 for 1 kilogram of bananas in Winnipeg. That same cost for 1 kilogram in Little Grand Rapids is $4.65 per kilogram. So the question is, what is the difference in price for the 2 communities? Then I would have to take the cost of 1 kilogram in Little Grand Rapids, subtract the cost in Winnipeg, and the difference, therefore, the difference is $2.99 per kilogram in the two communities. Question number 13 says the table compares the typical monthly cost of electricity for several appliances. What is the hourly unit cost? So hourly unit cost means my hour and my cost. I want to figure out how much it is per unit of hours. So if it is 240 hours and it's $12.11, I want to know how much does it cost me to run my fridge for 1 hour. So if I take the $12.11 and divide it by 240, I realize it costs me just a little bit more than a nickel per hour to run my fridge. So the unit rate for the fridge would be $0.05 per hour, or a nickel an hour. For the computer monitor, it's $4.26 for 120 hours. Take my $4.26 and divide it by the 120 hours it's on for. It costs 0.0355 cents for 1 hour, or almost just a little bit more than 3.5 cents per hour. So I'm going to put approximately, I'll round it up to the nearest cent, approximately 4 cents per hour. The television, $3.46 for 180 hours. Divide your 3.46 by 180 hours. It's roughly, almost, approximately 2 cents per hour. And your last question, $3.99 for 15 hours. Treadmill's quite an expensive thing to run. $3.90 divided by 15 hours it's on. It costs about 27 cents per hour to run. Oh, I made a mistake. I didn't read the entire question, did I? Okay, you're not supposed to round it to the nearest cent. You're supposed to round it to the nearest tenth of a cent, which means I needed to keep 3 decimal places, not 2. Oops. Which appliance has the lowest rate of consumption? The answer is therefore the television has the lowest rate of consumption at only 2 cents per hour. Question 17 says, Shelly rode her mountain bike at a rate of 30 kilometers an hour for 2.5 hours, and Josh rode his mountain bike at a rate of 35 kilometers an hour for 1 hour, and then slowed down to 25 kilometers an hour for 1.5 hours. Who traveled farther in 2.5 hours? So if we think about these two speeds, and I'll change the color here for a second. If Shelly rode 30 kilometers an hour for 2.5 hours, then if I just drew a picture here and I'll put Shelly starts here. The first hour, she went 2.5 kilometers because she went 2.5 kilometers per hour. Sorry, 30 kilometers. Sorry, I'm mad. Oops. 30 kilometers in the first hour. In the second hour, she would have went another 30 kilometers. And in the half hour, and she went 30 kilometers an hour, she would go another 15 kilometers in that 2.5 hours. So therefore, she would have traveled a total distance of 75 kilometers in 2.5 hours. Now the other person, Josh, he went 35 kilometers in the first hour. And then he went 25 kilometers in the second hour. And in the next half hour, he went half of 25 kilometers, which is 12.5 kilometers. So he went 35 plus 25, which is 60. He went 72.5 kilometers in 2.5 hours. Okay, what's the difference in the distances? What's his name? Josh went 2.5 kilometers further. Question 15, determine the missing value of each rate. Sorry, determining the missing value if each rate is equivalent. Give the unit for each. So since this is in months and this is in months, I can consider this to be X, and I could do this one of two ways. I could say I divided 4 months excuse me, I'll just change this. I divided 4 months by 4 to get 1 month. And if I divide 64 kilograms by 4, I'm going to get 16 kilograms. And therefore, the missing rate would be 16 kilograms per month. Here, if I think of it as using division, if I divide both by 8, I will get the proportionality of the second rate, which means that 84 divided by 8 is 10.5. So therefore, it's $10.50 per 100 kilometers. And the last one, if I don't know that 80 times 9 is 720, then it's going to be difficult. But since you can multiply it by 9, you would get 18 minutes for 720 beats. If you did not know that 9 was the multiplier, an easier way you could have solved this was by cross multiplication. Make this your x and say 80x is equal to 1440. Divide both sides by your 80 to get your value of x, and x will equal 1440 divided by 80, which is 18. Same answer I got before. Your next question says use a proportion to solve each question. Use a variable for the unknown quantity. 3 bars of soap cost $2.94. What is the cost of 8 bars? So $2.94 for 3 bars is proportional to how much for 8? Since 3 times whatever, it does not work out well. So for this one, what we could do is we could solve it one of 2 ways. We could either figure out the multipliers one way. We could figure out, since that's not the easiest way, because obviously it's difficult to figure out what 3 times 1 is 8. An easier way I could do it would be to figure out what 1 bar is. So I could take $2.94 and figure out what 1 bar is, and then figure out what 8 bars is. That's another way. But of course, we've learned that the easiest way to solve it from a algorithm perspective is simply to multiply across to get 3x, multiply across to get a product of $2.94 and 8, which is $23.52. And then if I divide $23.52 by 3 to isolate the variable, I get $7.84. So x equals $7.84. So if it's $2.94 for 3, it's $7.84 for 8. And on a map, 1 centimeter represents 150 kilometers. On a map, how many centimeters represent a distance of 800? So we're going to put map to real. And therefore, 1 centimeter to 150 kilometers is proportional to how much in the map for 800 kilometers. If I use cross multiplication, I get 150x equals 800. Divide 800 by 150. And I get 5.3 repeating. So x equals 5.3 repeating. Or a better way to put that would be 5 1/3 centimeters. Question 17. A mass of 5 grams of stretches a rubber band by 15 millimeters, excuse me. If the rubber band stretches at the same rate, find the following. So we're going to put mass to stretch. All right. And if 5 grams of mass stretches at 15 millimeters, that should be proportional to a mass of 28 grams will stretch it how far? So 5 times what is 28? You could do that. Or 5x equals the product of 28 and 15. 28 times 15, which is 420. So 5x equals 420. Divide by 5. And you get x equals 84. And therefore, it will stretch 84 millimeters. That's your answer to A. What mass would stretch a rubber band 32 millimeters? So I'm going to take that same initial stretch. 5 grams will stretch at 15. Will be proportional to how much mass for 32? My equation this time will be 15x equals 160. Divide by 15. And x will equal 160 divided by 15, which is 10.6 repeating, or 10 2/3 centimeters, millimeters, sorry. And finally, your last question, C. What mass would stretch a rubber band to 9.9? Give your answer to the nearest tenth of a gram. So 5 grams will stretch it 15 millimeters. What would stretch it 9.9 centimeters? Very important you see centimeters because 9.9 centimeters is actually 99 millimeters. So if we have millimeters as our second unit in the first rate, then it has to be millimeters in the second rate as well. So I have to change 9.9 to 99 millimeters. And put x here. So our equation, when we multiply across here, will be 15x equals the product of that, which would be 500 less 1, which would be 495. Divide both by 15. And 495 divided by 15 is 33. Did I make a mistake there? 500, no, that should be right. Huh. Yeah, so 33 grams. And question 18, your last question. The height of an object compared to the length of its shadow is constant for all objects at a given time, much the same as the question we did in 2.3. Use this information to and a drawing to help answer the following question. So a 20-meter tower. So this is my 20-meter tower. That's a terrible tower. There's the door. There's the window up top. So a 20-meter tower casts a shadow that is 12 meters. What is the height of a tree whose shadow is 3 meters long? So there's my picture. And if I write my proportion, I'm going to go object to shadow as the ratio. Okay? The object in the first one is 20 meters, and its shadow is 12 meters. This will be proportional to the object that I don't know, which is the tree, to its shadow, which is 3. Now, if I'm looking at what method would be the most appropriate here, obviously, since 12 divided by 4 is 3, the most appropriate method would be division, and therefore I know the tree is that tall. Okay? Now, the important parts, if you're thinking about what you need to do, is I started with words, I substituted my numbers, and I kept those numbers proportional. Object was always on top, and shadow was always on the bottom. In B, if a 25-meter building, so I'm going to do another building here, a 25-meter building, so this is 3-window building, it seems reasonable. 25-meter building has a shadow that is 8 meters tall. That is proportional to a 1.6 meter person. And how long is its shadow? X. So again, same thing as I did before. I'm going to put object to shadow, and that's the ratio I'm going to have. So I'm going to make sure that, and it doesn't matter if you had shadow to object, as long as you keep object to shadow. So the object, my first ratio is 25 meters. Its shadow is 8. It is proportional to 1.6, I know, because that's the height of the person, to the unknown shadow. Here I don't know what I divide 25 by to get 1.6, so I'm going to use my cross multiplication. 25x is equal to 8 plus 4.8, which is 12.8. I think that's right. I better use a calculator because I don't want to make a mistake here. So 8 times 1.6 is 12.8. Good. Then take that and divide it by 25. I get x is equal to 0.512. So therefore the shadow would be 0.512 meters or 51.2 centimeters.